Hey everyone, welcome back to Collapsed Latents. This week in AI, your weekly deep dive into the most groundbreaking research pushing the frontiers of artificial intelligence. I'm your host, and this week, we're not just talking about smarter models, we're talking about new ways of thinking. From agents that collaborate in silence, to world models that generate real-world skills without a single robot move, to video models that learn during generation. This is AI evolving not just in capability, but in cognition. So grab your coffee, hit subscribe, and let's break down 5 revolutionary papers that are redefining how AI sees, thinks, and creates. #1. LatentMAS, where AI agents think, not talk. Imagine a team of AI agents working together, not through endless back-and-forth text, but in a shared, silent language of thought. That's LatentMAS, a training-free framework that lets large language models collaborate entirely in their internal latent space. No tokens, no re-encoding, no semantic drift. Instead, each agent generates latent thoughts, autoregressive sequences of last-layer hidden states, and shares its full reasoning pipeline via its key value, KV, cache. That's right, Agent A doesn't say, I think 30 Bs left. It transfers its entire mental state to Agent B, who then reasons on top of that with perfect fidelity. Why does this matter? Because text is a bottleneck. Every word is a lossy compression. But latent representations, they're continuous, dense, and exponentially richer. Our analysis shows a 14B model can express the same reasoning in 471 times fewer steps, while preserving full meaning. And the results? Stunning. 14.6% higher accuracy on math and code benchmarks. 83% fewer output tokens. 3 times faster inference, even faster than optimized text systems. We tested it on a classic math problem. Deborah sees 30 Bs leave, half return, then twice as many leave, then all that left but didn't return come back. How many return? Text-based systems fail here. Misreading, half that many leads to cascading errors. But LatentMAS, it sees the entire reasoning trajectory, uncorrupted. The answer? 75. Correct. In fast, this isn't just efficiency, it's a paradigm shift. We're moving from language as a medium to thought as the protocol. And it's all plug and play. No training. No reconfiguration. Just pure, silent collaboration in the mind of the model. #2. GigaWorld 0, the synthetic world that trains real robots. Now, what if your robot could learn without ever touching the real world? Enter GigaWorld 0, a unified world model framework that's not just a simulator, but a data engine for embodied AI. It generates photorealistic, physically grounded and instruction-aligned training data at scale, all synthetic. Why is this a game changer? Because real robot data is slow, expensive, and hard to scale. Simulations are often too fake. But GigaWorld 0 bridges the gap, creating data so rich, so diverse, that VLA, vision language action models trained on it perform flawlessly in the real world, even if they've never seen a real robot. It's built on 2 pillars. GigaWorld 0 Video, a mixture of experts video model trained on embodied interaction data. It uses 3D VAE compression, sparse attention, and FP8 precision to run efficiently, while generating videos with 50 times faster inference via denoising distillation. GigaWorld 0 3D uses 3D Gaussian Splatting to build high-fidelity scenes. It reconstructs backgrounds from sparse views, generates physics-aware robot arms via differentiable PINNs, and even turns human demonstrations into robot-executable actions. And the pipeline? Fully modular. FG generates assets from text. BG reconstructs environments. FIS infers physical properties. AC plans collision-free trajectories. The result? A robot folds laundry, prepares juice, and busses tables, not in simulation but on real hardware. The G1 humanoid and Piper arms succeeded, even under novel lighting, textures, and object placements. This isn't just synthetic data. It's a self-improving loop. Real-world experience feeds back into the world model, creating lifelong learning. GigaWorld 0 is the foundation for a new era, where the future of robotics isn't built on data collection, it's built on world creation. #3. PRFL, rewarding AI video generation during the process. Let's talk about video generation and the painful truth. Reward models are too slow. Traditional methods wait until the final frame to evaluate quality, by which time the model has already made irreversible errors. Enter process reward feedback learning, PRFL. A radical idea. Use the video model itself as a reward engine in the latent space during generation. Instead of waiting for full denoising, PRFL samples a random time step, say t equals 0, 6, and evaluates quality from the noisy latent. It repurposes the model as a process-aware video reward model, PAVRM, trained on human preferences to detect motion quality, anatomy, and plausibility, even in high noise. Then, during training, it computes the reward, backpropagates gradients through the entire denoising trajectory, and guides the model from step 1. The results? Massive gains. +56 in dynamic degree. +2152 in human anatomy. 30% faster training. Only 67 GB VRAM, no GPU crashes, even on 81-frame videos. Human evaluations with 30 professionals confirmed it. PRFL beats SFT, RWR, and RGB Ray-FL in motion smoothness, text adherence, and naturalness. And here's the mind-blowing part. The PA-VRM generalizes across models. Trained on 1-to-1, it accurately evaluates Hunyuan video and VO3, because it detects universal structural errors, not model-specific quirks. PRFL isn't just faster or better, it's a new philosophy. Not judge the outcome, but guide the journey. We're no longer waiting for the final frame. We're teaching the model how to build a good video from the very first noise. #4. Canvas to image, drawing your vision, not just writing it. Now imagine you're an artist. You don't want to type prompts. You want to draw your scene. Place 4 friends at a table, sketch their poses, label their names, add bounding boxes, all on one canvas. Then click Generate. That's Canvas to image, a unified framework that collapses all control signals, text, pose, layout, identity, into a single RGB canvas. No more juggling ControlNet, IP adapter, or segmentation masks. Just one interface. One models. It uses 3 specialized canvases. Spatial canvas, composite images with cutouts, but with cross-frame sampling to avoid copy-paste artifacts. Pose canvas, semi-transparent skeletons over spatial layouts, letting the model learn pose control independently. Box canvas, bounding boxes with text labels, giving direct spatial constraints. The magic. Multitask training. The model learns all 3 in a unified curriculum. Then at inference, it generalizes to combinations never seen before, like pose plus layout plus identity, all in one go. How? A simple task indicator token like pose or box tells the model what kind of control it's receiving. And the results? Stunning. 0.592 arc face similarity on 4P composition, far ahead of QN image edit, 0.258. 4.469 control QA on pose overlaid tasks, the highest ever. No hallucinations, no artifacts, just coherent, natural scenes. This isn't just a tool, it's a creative interface. You're not writing prompts. You're drawing your vision. And the AI understands it, not in words, but in visual logic. #5. Chain of visual thought, when AI thinks in vision. Finally, let's talk about vision language models, the ones that describe images. But here's the flaw. They translate vision into language, losing critical perceptual detail. How many clouds? Which object is closer? A human sees it. A VLM guesses. Enter chain of visual thought, CoVT, a framework that lets VLMs think in visual space. Instead of just generating text, the model predicts visual tokens, compact, dense representations encoding segmentation, depth, edges, and semantics. These aren't outputs, they're intermediate steps in reasoning. During training, the model predicts these tokens, and a lightweight decoder reconstructs the original visual signal, like a depth map or mask. The difference trains the model to internalize perception. At inference, it can reason directly in visual space, then optionally decode for interpretability. The results? A leap in visual grounding. 5% plus improvement on spatial reasoning. 16% better depth estimation. On a counting task, it caught a hidden object the baseline missed, because it saw the boundary and depth layering. And the transparency? You can decode the visual tokens and see how the model made its decision. Want to know why it said, the wall has a painting? Decode the segmentation and depth, and there it is, a vertical shape with a depth discontinuity. This isn't just better performance. It's explainable AI, where the model doesn't just answer, it shows its thinking. So what's the thread tying all 5 of these breakthroughs together? They're not just incremental improvements. They're a shift in the very nature of AI cognition. LatentMAS lets agents think together, not speak. GigaWorld 0 lets robots learn in synthetic worlds, not real ones. PRFL teaches video models during generation, not after. Canvas to image lets creators draw their vision, not type it. CoVT lets VLMs think in vision, not language. The future isn't about bigger models. It's about deeper, richer, more grounded ways of thinking. We're moving from language as the medium to perception as the foundation, where AI doesn't just describe the world, it sees it, feels it, and reasons within it. If you're building, researching, or just fascinated by the next wave of AI, this is the moment. Check out the papers, the code, the models, all linked in the description. And if you found this deep dive valuable, like, subscribe and hit the bell, because the future of AI isn't just coming. It's already here. See you next week on Collapsed Latents, This Week in AI.